Hello all, welcome back. In this video we'll see TinyLlama implementation with CAN within Intel NPU. My name is Abhishek Nandi. I am PhD scholar with Industrial IoT and AI. So what are we trying to do? The code demonstrates how to integrate CAN, Knowledge Acquisition and Augmentation Network, also known as Kolmogorov's-Arnold theorem, layers into TinyLlama model potentially compiled for Intel NPUs to enhance language understanding and extract insights during the text generation. So as we can see from the code explanation itself, first of all we bring in all the libraries, that is the transformer code library for working with large language models, collection DQ for efficient handling of context tokens, Intel NPU acceleration library for compiling the model to run on Intel NPU. That's our target. We are using torch and torch.nn deep learning essentials used for utilizing the tensors, other modules for handling types, warning and file paths. Model ID is the TinyLlama LLM that we are using from Hugging Face. We are using a cache directory location to store the model for faster loading, and we have made a maximum context length, that is a size of 4096 for the token utilization. So what we are trying to do in the TinyLlama, we are designing a custom class, that is the CAN class we have, where it inherits from auto model for casual LLM, the base class for language casual language models. We are adding in CAN layers, two linear layers to process the hidden states. As you can see in the code itself, I will open up the Visual Studio Code. First of all, we are bringing in all the libraries that are needed. Then we are using the model ID, that is for TinyLlama. Then we have the model cache that needs to be done. Why we have done is this model caching is this: if we are downloading the TinyLlama for the first time, then you run it again, it loads from your local machine and runs the LLM. We have the maximum context size of 4096. Now we have made a custom class model that is known as CAN model itself. So this particular network that we see over here, it inherits from the class from auto model for casual LLMs, base class for casual modes with Hugging Face, that all we have already mentioned. CAN layers, we are adding in two linear layers, where you can see this part where we are adding in the linear layers which are designed to process and transform hidden states, these hidden states within the model. These layers are also used for utilization itself. Now we are doing our forward pass. So forward pass, what it does is that it loads the model, overrides to the cache, and forward method is overridden to incorporate the CAN layers. Okay. Now after that, the standard forward pass of the base model, the last hidden state are processed by the CAN layer before being returned, as you see over here itself. Now we are loading the model with caching capabilities. We are evaluating the model. We are directly putting the model into Intel NPU for compilation, and we are suppressing the warnings. We are just using the context and the input handling for the starting point, and we can quit the conversation using quit or exit. And here we are using the first generation of CAN that we have generated for model dot generate using model dot generate, and we are handling the hidden states for CAN processing. And finally we are analyzing the relationship as well as the insights into it. So as you can see, we have implemented this for TinyLlama that is added with a CAN network, or what we can say that Kolmogorov's-Arnold network itself. To see it in action, what we have done is that we have used the task manager to represent the NPU and the code will run side by side over here to check the utilities of it. Now if I say, like, already the code is running, and if you see right now that the CPU utilization or the NPU utilization over here is completely 0. Now I will ask a question like, can you help me with pen? It will generate a context regarding that. So you see the utilization of NPU over here, it goes to 53 right now, and it is utilizing the shared memory too. So accordingly it goes for all the information that is there, and after that it gives a warning and goes out of the context. Again, if I ask question like suggest some details about batteries. Okay. So again you see the utilization over here, it goes to the information and gives all the details of it. So similarly what you can see is that we have used Intel NPU and TinyLlama with CAN implementation, and it's a experiment that I was trying to do. I went through the paper and analyzed certain things and created the same so that I can show how CAN layers can add to LLMs and can also improve the performance, or what are the things or experimentation that we can do. Hopefully you will you have liked the video. Thank you.